So let us discuss about the AC applied across a purely capacitive circuit. Suppose we have a capacitor, let's say a capacitor having capacitance C, which is applied an AC. This is the AC of V volt, and we know the EMF of AC always varies, and we have V equal to V0 sine omega t, where V0 is the peak value of the AC voltage, omega the angular frequency, and t is the time. And we know there is always a current flowing through the circuit, and we know the direction of the current instantly changes. Let's now consider it is in the clockwise direction. In the next half cycle, it will flow in the counterclockwise direction. So let's say let C be the capacitance of the capacitor. Then we have the charge accumulated at any instant. We have charge, let's represent it as Q, will be the capacitance time the voltage at that voltage. That's the expression for the charge. We have charge is equal to capacitance of the capacitor into voltage. When you substitute the value of V, that is V0 sine omega t, we have C into V0 sine omega t. Call this as equation number 1. Now from the charge, how will you find the value of current? The current at any instant will be the rate of change of charge with respect to time, or the derivative of charge with respect to time. So it will be d by dt of, you can substitute CV0 sine omega t. Since this capacitance and peak voltage is constant, you can take that out, CV0 d by dt of sine omega t, which is equal to CV0, derivative of sine is cos omega t into omega. Clear? So the current is equal to C omega V0 cos omega t. This can also be written as I is equal to V0 by this omega c can be taken to the denominator. It will be like this, 1 by omega c cos omega t. Clear? This is the expression for current. Again, you can simplify, that is I is equal to V0 divided by 1 divided by omega c. C, we have sine 90 plus theta, that is 90 in radian, it will be pi by 2 plus theta is equal to cos theta. 90 plus theta is sine 90 plus theta is cos theta. So instead of cos omega t, you can write sine pi by 2 plus omega t. Or let me represent this as I0. So we have the final expression I is equal to I0 sine pi by 2 plus omega t, or omega t plus pi by 2. So this is the expression for the current at any instant in a purely capacitive circuit. Now we can note certain points in here. Let's talk about the magnitude of peak value of current first. that is I0. When you compare these two equations, you know I0 is actually V0 divided by 1 by omega c. When you compare the value, this value or this equation with the Ohm's law, we have current I is equal to voltage by resistance. So here the 1 by omega c stands for resistance. But this time it is not the resistance offered by the resistor, it is the resistance offered by the capacitor. So we call that as capacitive reactance. Capacitive reactance. It's nothing but the resistance offered by the capacitor to the flow of AC. So this is the value of capacitive reactance, or you can write X is equal to 1 by, instead of omega you can write 2 pi f into C, where omega is actually angular frequency equal to 2 pi times the frequency of the AC current. Clear? And you know, let me write the expression for voltage here. We have V equal to V0 sine omega t. Now, if you compare the value of voltage and value of current at any instant, we have current is always omega t plus pi by 2. So you can say that current I leads the voltage. Leads the voltage by a phase of or phase angle of pi by 2. Which means current is always ahead of the voltage, or in other words, voltage lags behind the current by a phase of pi by 2. Clear? Now, if you draw the phasor diagram, before that we have to draw the x and y axis. This is the y-axis, this is the x-axis, and let's represent the voltage first. That is, this one is the voltage, or let's say the peak voltage. It is at an angle of omega t. We know the peak current is always ahead of voltage, so you have to draw the current like this. Clear? This is the value of peak current, and the phase angle between the voltage and current is always 90 pi by 2. Clear? So this is the phasor diagram of purely capacitive circuit. Now let's draw the graph of AC voltage and the instantaneous current. Clear? You understand this? Now let's draw the graph of AC and AC current and the voltage. See, let me draw the axis first. Let this represent, the x-axis is represented by omega t, and let's mark here the peak voltage V0. Below it, let be the I0. Here also it is minus I0, and here it is minus V0. On the x-axis, on the y-axis, we can represent both the voltage and current. Let's mark the point in terms of angle, that is 0, pi by 2, pi, 3 pi by 2, and 2 pi. Let's draw the graph of voltage first. So we have V0 sine omega t. When omega t is 0, voltage is also 0. When omega t is equal to pi by 2, sine pi by 2 is 1. So V equal to V0. So when omega t equal to pi by 2, V equal to V0. Again, when omega t equal to pi, then we have V equal to 0. When omega t equal to 3 pi by 2, we have sine 3 pi by 2 is equal to minus 1, which turns V to minus V0. So minus V0, again 2 pi, it is 0. So the voltage graph is like this. Now let's draw the graph of the current, instantaneous current. Suppose when omega t equal to 0, we can write I is equal to I0 sine. When omega t is 0, we can write 0 plus pi by 2, which means I0 sine pi by 2 is, sine 0 plus pi by 2 means sine pi by 2. So the value becomes I0. So when there is no, or when omega t is 0, we have I equal to I0. When omega t equal to pi by 2, that is pi by 2 plus pi by 2, it will become pi, then I equal to 0. Sin pi is actually 0, so I becomes 0. Again, if you take omega t equal to pi by 2, pi, this will become pi, and pi plus, there is a pi by 2, which becomes pi plus pi by 2 is 3 pi by 2. Sin 3 pi by 2 is minus 1. So I becomes I0 at omega t equal to pi. So here. And if you draw like this, you will get a graph like this. This is the plot of the current. That is, this one is V equal to V0 sine omega t, and this is the graph of I equal to I0 sine omega t plus pi by 2. Clear?